begin with, the situation of climate science, or the way it might be portrayed in the media, right? So there might be some deniers saying, well, there is actually no consensus, but make no mistake, the science is clear. And I'll do a bit of a cheeky thing. I'll give you a climate change 101 in 10 seconds. You can stop me from now. So 1, it's happening. 2, it's us. 3, we're sure. 4, it's bad, it's extremely bad. And 5, we can stop it, or at least prevent the worst. Right? I would maybe normally go a bit into the details of this, but I think I'm guessing you I'm guessing this is the bit that people are roughly familiar with, otherwise we'll talk about it later. The thing that I'm really interested in is these two things. To convey you the urgency of the situation, and I'm going to say it's an emergency, and to talk about the fact that, and especially how we can stop it, or at least prevent the worst. Just before I go into the climate emergency, I just want to mention before it kind of falls off the table, because it isn't explicitly mentioned here. We're not only in a climate emergency, we're also in an ecological emergency that is related to biodiversity loss, to species extinction, which is accelerating at an unprecedented rate and is threatening up to 1 in 4 species on the planet, with massive impacts on ecosystems, obviously, but also on human society. Okay, well now I'll focus on the climate emergency. So are we in one? Well, as you've heard, Extinction Rebellion, I'm quite clearly making the case, and I've put this on the agenda. What do scientists say? Jefim is one of the most renowned climate scientists in the world, I would say, says, based on sober scientific analysis, we are deeply within a climate emergency state, but people are not aware of it. And James Hansen, another world-renowned scientist, climate scientist, says we are in a planetary emergency. So what's this climate emergency all about? What we've got here, and you've probably seen this before, is CO2, carbon dioxide, in blue, and temperature in red, going back 800,000 years. Let's see, yeah, this way, this back in time. And as you can see, CO2 goes up and down with the glacials and interglacials. Temperature follows CO2, or the two are linked in ways. But then what's happening here, basically in the last few hundred years, is that CO2 just shoots up way beyond anything we've seen in the last 800,000 years, way beyond the range that's happening between glacials and interglacials. And then the question is obviously, well, okay, one thing to mention, so this is the range of between the Holocene, the last 11,000 years, and the Ice Age. And this is what's been added just in the last 150 years. The question is then what happens to temperature, right, since they've been linked so closely. Okay, and what is happening to temperature is it's leaving the range of the Holocene. It's basically, a new climate era, you could say, which basically means we're in a state of fundamental uncertainty. So what you see here is the temperatures since basically 1850, and this was supposed to be pink. I'm not sure you can see it's pink. This range here is the temperature range of the Holocene, and we're now moving outside of that range. And that is now. How is that going to look for the next decades and the next century? So now we've got, on this figure, we've got temperature again, temperature anomalies over the last, going back 20 million years here, and then kind of going in, zooming in a bit in the last 100,000 years, and then here the present. So we're here somewhere. And what you can see here is, depending on different scenarios of societal development, basically, we see different responses in global temperatures. And the important thing is, what's written up there is, we're basically on track to catapult the Earth into a state that is hotter than anything humans have seen, and indeed the human species. So if you look at this is what I mentioned before, this bit here is the Holocene. This is basically the time since which Homo sapiens has been around, and this is basically Homo anything, if you will. And just by 2050, if we follow the trajectory we're currently on, we'll go into a state that hasn't been seen since the human species, or the human race really has been around. So I think that's reason for concern. Right, okay, so what will that look like? One thing is we'll see basically more of all things terrible. So Kate Marlowe puts it this way: as the average temperature warms, the abnormal becomes the new normal, and the new abnormal becomes the unprecedented. So if you look at a distribution of, for example, temperatures, this dashed one here was the old distribution, so what was hot here, now with the new distribution in the bold black line, you'll see much more of what used to be extreme hot, and then the new extreme is just way off the spectrum of what we had before. Okay, and that will translate into more frequent and more severe heat waves and drought. And you remember the one from this summer, I'm guessing. Wildfires as well. We had one in February this year. And flooding and storm surges, obviously, also is something that is quite traumatic in the memories of Leeds residents, I guess. And it means regions can become totally uninhabitable because of sea level rise. So this is a map, basically a projection of what the UK and parts of Europe will look like for a 9 meter sea level rise. So like 9 meter sea level rise is not around the corner, it's not going to like be there in 20 years, but it's something that that our trajectory might commit us to, and that trajectory within the next few decades, and basically the global development of the next few decades might lock us into this pathway. So you can see what happens here to parts of Yorkshire, and obviously also what happens to the Netherlands. But there's other regions that are affected right now, basically. So this is Bangladesh, and this is what happens to Bangladesh at just 1 meter of sea level rise, which is definitely more around the corner. And already then 50 million people will be affected in a huge area. The other reason why regions become uninhabitable is because of heat stress, because basically in some regions the heat just gets too oppressive for humans to survive in. So this is a map of, in a high emission scenario, how many days a year would there be levels of heat that are basically lethal for human beings. And as you can see, there's regions where this is 200, 300 days a year, right? So there's basically regions that in a high emission scenario, eventually we'll see conditions, many days a year, sometimes almost around the year, that are not really feasible for human survival. Okay, food and water will be impacted. Food production is significantly impaired under climate change. And Dr. Peter stopped it this way: it becomes really difficult to see at such levels of warming how we're going to maintain our agriculture such that the population of the world can actually feed itself. We've already seen water crises this year in India, in one of the biggest cities in India. The city ran almost completely dry. And again, these things are obviously going to escalate with increasing warming. All of these things point to climate refugees, and the projections are in the range of 150 million, 200 million climate refugees, but there's also estimates that go up into billion. So there's people that will be displaced or are at risk of being displaced, and that will have to go somewhere. So that's a massive issue. Disease is spreading, and all sorts of public health issues come up. Undernutrition is related to food production, heat, as I mentioned, and things like malaria and dengue fever spreading. And so a co-chair of the Lancet Commission says climate change is also a medical emergency. The medical community is basically as alarmed. And I think this is really important. So there's sort of the direct physical impacts, but then it's the human and societal interaction with those impacts that I think is the real big potential danger. And basically I think all impacts on climate change supercharge the potential for crises and violent conflict. So in that, in that climate affects food production and water, it exacerbates the risk of food crises, of famines, of water crises. That's also obviously something to do with governance, but the higher sort of the stress on the environmental provision, the more likely these things are to happen. And it might even lead to, I guess it's almost quite likely to lead to conflict and war over food, over land, over water, over resources, and linked to the issue of migration, over national identity, and obviously the uptake of refugees itself. So I find this quite telling. This is from the report that I've shown you on the left. Security risks at high degrees of climate change seem likely to be of a different order of magnitude, that means tenfold or more. Extreme water stress and competition for productive land could both become sources of conflict, and the risk of state failure could rise significantly, affecting many countries simultaneously, even threatening those that are currently considered developed and stable. So I guess that means the UK. And the president of the World Bank puts it this way: climate change will lead to battles for food. Okay, so if we put all this together, what is at stake here? Well, I guess quite a lot, right? So basically, we're talking about millions, possibly billions of people suffering, living in basically a state of chaos. And millions, and depending on the social responses, possibly billions could die. That is within the realms of what we're talking about here. John Rockstrom, another highly renowned Earth system scientist, says at 4 degrees of warming, it's difficult to see how we could accommodate 1 billion people or even half that. There will be a rich minority of people who survive with modern lifestyles, no doubt. There will be a turbulent, conflict-ridden world. Right, this is an assessment, this is not certainty, but this is sort of on the horizon. Right? And collapse of human civilization, there's several people saying that, basically the collapse of organized life and international order. So, again, Hans-Joachim Schellnhuber, when asked, what's the difference between a 2C world and a 4C world, the difference is human civilization. And Joseph Stiglitz, one leading economist, says the climate emergency is our third world war. Our lives and civilizations as we know it are at stake, just like they were in the Second World War. And this has been recognized by the atomic physicists that govern the bulletin of the atomic sciences, I think it's called, that have this thing called the doomsday clock, which basically is a measure representation of the existential risk to humanity. And since a few years, this has been moved forward explicitly due to climate change. And in 2019, it's still at one of the highest levels throughout the existence of the doomsday clock that it's been, saying that's because of lack of progress on nuclear risk, which is one of the big ones, but also on climate change. Okay, so what do all these things imply? Well, I think they imply that this is really an overriding priority for everyone, for every body of governance, all sorts of organizations, trade unions, and individuals. And I think it's quite important to understand that that means if everything is at stake, that we can't take for granted the ways of life, the societies we're currently seeing and enjoying to some extent. So since the way our societies are being organized right now are fundamentally threatening, well, basically human civilization, I think we need to put into question all sorts of systems, all sorts of things we've got used to. So Ban Ki-moon, the former UN Secretary General, says this is an emergency, and for emergency situations, we need emergency action. So what would it take to tackle the climate emergency? And that's going to be the second part I'll talk about. It would take very rapid global reductions in CO2 and other greenhouse gases. And basically, what these curves show you is, so these are CO2 emissions over time. In order to stay within 1.5 degrees of warming, which is deemed relatively safe, we need to reduce really quickly. And the more we wait, if we start reducing later on, the more rapidly we have to reduce to still stay within 1.5. And basically just a few years, that's what we're here. Are we? Yeah. So basically just a few years down the line, we've sort of burnt it. So like 9 years of current, or less than 9 years, almost 8 years now of current emission means we've sort of, we've burnt the budget. Okay, how are we doing then? Well, we've had the Paris Agreement, right? And that was kind of seen as a bit of progress. And the UK Parliament has declared a climate emergency, also an ecological emergency, by the way. And then this year, a law has been passed for incorporating net zero by 2050. However, what trajectory are we currently on globally? So the baseline case, which means basically business as usual, might lead us somewhere here, approach of almost 5 degrees. The current policies, somewhere around 3 degrees, but that's a range between 2.5 and 4 degrees. And that's basically the Paris pledges, which is around 3 degrees, but also almost to 4 degrees. But bear in mind that Paris is non-binding. Yeah? And bear in mind that 4 degrees is this state where scientists say everything is at risk, basically. Okay, so on the net zero law and the net zero 2050 date, is that a sound strategy? It's a good start, I would say, but there's 3 main issues. One is it relies heavily on carbon capture and storage and the combination of that with bioenergy. And that's basically unproven technologies. They're not proven to work at scale. Well, they're basically not even proven not to leak. And it will take lots of time to roll them out. It's going to be very costly. And there are sustainability issues related to bioenergy and how it competes with food production. And obviously it's also an issue for biodiversity loss. Secondly, it's a really big but. The CCC omits all emissions that are associated with imports to the UK, and that's 46% currently of the UK carbon footprint. So that's the green bit in here. That's the bit that they sort of don't take into account into that equation. So that's the issue. Yeah? And that's obviously directly a matter of global climate justice and a matter of climate safety. Either it means, well, okay, we're going to go over the target, then we're not going to meet 1.5 if we sort of forget this bit, or we shift the burden to other countries that produce the stuff that we live off, you know, our food, probably most things in this room. And thirdly, and that's I guess more an issue of government, is that the actions that we're currently seeing are just entirely inconsistent with this objective. You know, continuing with fossil fuel subsidies, we've eliminated the feed-in tariffs for renewables, and fossil extraction is still being supported. One key issue that I want to talk about is climate justice. I've just mentioned it a little bit, or climate injustice really. So the basic dynamics of climate change are such that those who've contributed the least are those who will be and already are hit the hardest by the impacts, and that are also the most at risk from being hit by climate mitigation policies. While those who've really contributed the most will be less hard hit. It's like, at this point, there's no one is safe, really, but they'll be less hard hit, they have more capacity to adapt. There's huge injustice in the emissions, if you look at them in an income perspective. So basically the 10 richest percent of the planet, of people on the planet, combined almost make up half of all emissions globally. And then the poorest 50% combined only amount to 10%. And this is really interesting. This is a world map of looking at the historical aggregate picture from basically the onset of historical industrial revolution, and looks at which countries then are the most responsible per capita. And this is really important when people start telling this like blame it on China story, right? China is very green in the historical picture. The UK is the reddest of all countries in the historical picture, right? We've got the highest historical capita emissions in the world. I can do later. So that means we have some sort of carbon debt. And the other bit of that is that many countries still face serious deprivation, hunger, no electricity access, no water access to their houses. So there's sort of basic needs that aren't met. That means that these countries need to put in place infrastructure to meet their basic needs, which will mean they will use some resources, they'll probably produce some emissions, which I think should be somehow accounted for in how the global emissions budget is allocated. Okay. Climate change, and I think this is really important, is a systemic issue, and that I think suggests it requires systemic solutions. This is what's called the Great Acceleration. This is looking at a number of indicators. I'm not sure you can see all of them, it doesn't matter in detail. Basically, this is a number of environmental indicators. Here, I think is temperature. No, sorry, here's temperature. Here's species extinctions, water use, ozone depletion, and so forth. They've all accelerated at an exponential rate over the last 150, 200 years. And why is that? Well, here's a strong candidate. Here's GDP, right? So economic growth, basically not economic growth, the scale of the economy, the scale of production, the scale of consumption, is basically bang on in the middle of this, and there's very strong economic theories and thermodynamic principles that suggest indeed that GDP is a key driver here. Okay, so these are interlinked issues: the climate crisis, the biodiversity crisis, also the crisis of democracy and the social injustices that we're seeing. They're all symptoms of a systemic issue which is related to our political economic system. I just said that. And importantly, so the social injustice bit, I think you mentioned that in your speech, goes down to the same root causes as the exploitation of nature, the destruction of nature, which is basically production for private profit, which is a sort of key tenet of capitalism. And it also means we're facing big obstacles here. Capitalism is entrenched in basically all aspects of society and all institutions, including in all sorts of law, in the foundations of our political system, in our constitution, in the representative democracy, which really is more oligarchic than democratic. And it's been turbocharged by neoliberalism. And we're facing powerful vested interests that want to maintain this status quo system that they're benefiting from. Right? So they're not neutral actors here. We're talking about the oil industry, the gas industry, the automotive, the aviation industry, agribusiness, and the military and arms industry, and media. Okay, so what do we need to keep in mind when we talk about emissions reductions? Well, it needs to be a just transition, right? We need to make sure people are not left without a job or not sort of inequitably impaired by this transition. And we must, as I said this earlier, we must not deprive people of their basic needs, right? They must still be able to make a living, basically. We must avoid regressive distributional impacts. So we need to be really careful with monetary instruments that tend to have, that tend to hit the poor the hardest, basically. And I think we should actually put in place special protection for the most vulnerable. And I think it's really important that we start to listen and include marginalized communities and stop with neo-colonial marginalization. So one way of doing that for really tricky questions, I think, is things like citizens' assemblies. Okay. I'm a bit conscious of time, so I'm just gonna... Yeah. Okay, I'm just going to give you a brief list of things. I'm not going to discuss them, just so you have an overview, yeah? Okay, so we need to shut down, not just ramp up. We need absolute reductions in activities, cars, flying, eating, consumption. Yes, we need technological change, but technological change alone is by no means enough, and it can backfire. There's the rebound effect, there's moral hazard. What would be elements to do this? Modal shifts, systemic alternatives, so bus, trains, bikes instead of cars, trains instead of planes, plant-based instead of meat. Things that reduce our necessity for high carbon activities, like insulating, less traveling, replacing business travel with video conferencing, tree planting and rewilding. Systemic changes, this is really key. Working time reduction. I think this is a big element in a just transition. Work sharing, same thing. These two combined have huge potential in a just transition. And this, the public provision of basic services, particularly with the idea of universal basic services, so universal healthcare provision, universal education, and those kind of things. Democratizing fixed business, job guarantee, perhaps the idea of public money. Okay, what are green jobs? It's not just renewable energy, it's not just public transport, right? A really important bit of green jobs is care jobs, retrofitting. We need an army of retrofitters. Healthcare, education, tree planting, of course, urban farmers, or farmers in general, repairing, all those kind of things, yeah? And there's lots and lots of, so this is like, this changes everything message. We're facing huge issues and we're sort of faced with really big threats, but there's lots of potential for improving our societies. In terms of health and mental health, air quality, importantly in terms of equity and justice, poverty, jobs, political participation, leisure time, community, purpose, and of course the avoidance of collapse. So one quite exciting development, I think, that combines a lot of these things that I've been talking about is the Green New Deal that currently Labour and the Green Party are supporting. I think it's a really radical and positive policy package. And I think the last thing I want to say is, how do we approach an emergency? If you think of a fire, and I know this metaphor has been sort of exhaustive, but I want to use it in a slightly different way, yeah? So fire is obviously an emergency. What happens if there's a fire? Does anyone start negotiating? Well, you're not doing your job, you know, you're not like pouring water on it. Does anyone start negotiating like, oh, we needn't start doing anything now, we can, you know, maybe it's fine if half the house burns down and then we'll start doing it. No, it's like, it's immediate, everyone does whatever they can. All hands on deck, clear focus, clear priorities, right? So maybe I'll just leave that there at the end and then stop and we can open up to questions. Okay, thank you.